Hi everyone, so it's Mrs. Slauson, and today in your packet we are going to be on page 17, and we are going to get the final piece together to learn how to graph. And so just kind of a recap of what we've done so far this semester, and even more so fourth quarter, is we first started working with factored form. And we use distributing, which if you're in my class, we called it the neighbors meet the neighbors, okay? And that took us from factored form into standard form. Then, and eventually, what we did is we did the opposite of that. We went from standard form to factored form, and we did that by factoring. And so we started when we factored with the GCF, and then if there were 3 terms, we made the x, and if there were 2 terms, we tried the difference of squares. So what we've been doing recently is going from standard form to vertex form with this process that's called completing the square. And that's where you group your x's together. That's where I showed you those algebra tiles. And so we grouped our x's together, and we put the non-x term outside of those parentheses because it didn't get to be grouped with the x's. And we took a number, cut it in half, squared it, and then we put those numbers in the box. So today what we're going to finally finish up is, what if you're given vertex form and you have to go to standard form? And so we're going to use what's known as the order of operations, which is a lot like this. These two kind of go together. So order of operations just means that we're going to be focusing on the parentheses first, because that's the first part of order of operations. We will not see an exponent because we're going to be getting rid of our exponent. And then we'll be doing a lot of multiplying next in order of operations, which is why I said it's similar to distributing, because distributing is multiplying. And then at the very end, we'll be doing some adding or subtracting. It just depends what we have in our expression with our terms. So let's just review before we get into vertex form to standard form, how we go from factored form to standard form. So again, it's just distributing. Some of you might have learned a trick called FOIL, first outside, inside, last, and if you're one of my students, you know about the neighbors meet the neighbors. So we're just going to walk through a couple of these, not necessarily all of them, because you've seen this before. So in the first factored problem, what we're going to do is distribute x to everything in here. So I have it, call it the neighbors meets the neighbors. So x meets x, and x meets the minus 5. And when we multiply, which is that distributing part, we're going to get x squared minus 5x. And then what we're going to do is distribute the 3 in. So 3 is the other neighbor that goes to meet everybody. And so when I multiply the 3 with the x, I get 3x. And the 3 with the negative 5 gives me negative 15. And if you remember, if you're one of my students, when we had the second set of distributing, which is what you see here in green, we started a new row and we would stack our like terms, like we used to in elementary school. And then I would drop down my x squared. I would combine these like terms, which you can't see that, is negative 2x, and then drop down that negative 15. And so now we are in standard form. So just a little bit of review, because we are going to be graphing soon. Remember, in standard form, you can see the y-intercept. All y-intercepts are when x are 0, and your y-intercept is this negative 15. And that just happens because if I put 0 in here, into this term, 0 squared is 0. If I put 0 into this term, 2 times 0 is 0. So you end up with 0, take away 0, take away 15, which is that negative 15. And then in factored form, we see the x-intercepts. And so a quick trick, which doesn't always work, but for now it is you can just take the opposite of the number that you see in the parentheses. So when I see a positive 3, I want negative 3. And then the y value is 0. Y is always 0 in an x-intercept. And then the opposite of this number, I would take 5 and get 5, 0. All right, in the next one, let's have the neighbors meet the neighbors. So x goes to meet everybody first, and you get x squared plus 5x. And then this negative 5 is going to go meet everybody or distribute, and you get a negative 5x, which I stack under the 5x because they're like terms. And when negative 5 meets 5, it's negative 25. And what I noticed in my classes, when the last terms multiplied, people really wanted to add those up. So remember, you're always multiplying when you draw those loops. So I'm going to drop down the x squareds. This time, when I combine my like terms, these cancel out. So I'm not going to write any term that has an x, and I'll just drop that negative 25. So now it's in standard form. I can see the y-intercept, that's 0, negative 25. Up here I can see the x-intercepts, so for this one, I do the opposite, so I get 5, 0, and when I do the opposite of this one, I get negative 5, 0. So let's do one more. Let's take care of this one down here. So in this one, there's an invisible negative 1 hanging out in front, and in this problem, you actually have 3 factors, or 3 neighbors, and so you can only multiply 2 things at a time, or in my class, you can only have 2 sets of neighbors meet. Okay? So what I tell my students is you should be like moths to the flame or mosquitoes to people, that when you see parentheses, you should just be drawn to the parentheses, and those are the neighbors I want you to start with. So what I always like to do, if I can find one, is take a sticky note and just cover the part that I'm not using for now so it doesn't distract me. So let's go ahead and have x meet everybody, or distribute, so I get x squared and 2x, and then the negative 6 will meet everybody, or distribute, and I get negative 6x and negative 12. And now when I combine my like terms, I drop this x squared down, these add up to negative 4x, and then the minus 12 drops down. And then I'm going to move my sticky note, bring this negative 1 down, and negative 1 now will distribute to everything. So when I do that, I get a negative 1x squared, which you could also just write as negative x squared. They like to leave that 1 invisible. Negative 1 and negative 4 is a positive 4x, and negative 1 with negative 12 is a positive 12. Okay? So that's just a little bit on review when you want to go from factored form to standard form. So now let's take a look at what happens when you have vertex form and you need to go to standard form. So the first thing what we want to do is we just want to write out the entire problem so that the squared exponent is gone. And if you remember the job of an exponent, it tells you how many times you're multiplying something. So this 2 says I'm multiplying x plus 3 twice. So I'm just going to write that out. And now I'm going to follow the order of operations technically, because what I want to do is look at my parentheses, and like I said before, when you see parentheses, you should be drawn to those. And what we're going to do is just multiply those parentheses. So what we just did. So x is going to distribute, and I get x squared and 3x. And then this 3 will distribute, or meet x plus 3, neighbors meeting the neighbors, and I get another 3x plus 9. When 3 meets 3, remember it's 3 times 3. So I'm just going to do what we did before, so this part is not new. And then this minus 4, which again, normally I would put that sticky note there. Now I'm going to bring the minus 4 back into the problem. And so now I'm going to finish up by combining my like terms, which these 2 are alike. So I'm just going to do this 9 minus 4. So when I'm done, I have x squared plus 6x plus 5. And so now I can see the y-intercept. It's 0, 5. And then in vertex form, you can see the vertex. And so those parentheses, if you remember, we always do the opposite. So I see a 3, I want negative 3, and then the number added or subtracted behind, that's the y value, but we won't do the opposite. We'll leave it as negative 4. So it's only in the parentheses that we do the opposite. So let's take a look at the next one. First, I'm going to get rid of that squared and write out x plus 1 twice. And then when you see parentheses, you should just be drawn to those parentheses. So I'm going to cover this 3 and cover this 2 because this is the only part I want to focus on. So let's go ahead and do all that multiplying and distributing. So I'm going to get x squared plus 1x. Then I'll distribute the 1 through and get another 1x. And then when these multiply, we get 1, not 2. So I'm just combining these like terms. And so now what I want to do is I still need to get through all this multiplying part. And so I'm going to uncover this sticky note because the 2 is technically multiplying to these things. So now I'm just going to drop that 2 down, right, and have 2 meet everyone. So we get 2x squared plus 4x plus 2. And then I'm going to bring that last sticky note uncovered, drop this 3 down, and then I'll combine my like terms. So 2 and 3 are alike, so it's going to turn into 2x squared plus 4x. And when I add the 2 and 3, I get the 5. So this one's y-intercept is 0, 5. And up here in the vertex, I can see -1 for the opposite in the parentheses, and then 3. And that's my vertex. So let's do one more. So for this one, I'm going to write out that squared, get rid of it. So there's 2x minus 1s. And now I don't want this minus 5 right now. And I also, here it is, don't want this -3. And I'm going to multiply those 2x minus 1. So let's quickly do that. So I get x squared minus 1x. Then I distribute or multiply this through, and I get another minus 1x. And then when -1 meets -1, I get a positive 1. So I'm going to add those up. And this is all what we just did on the other page. I still need to finish my multiplying according to the order of operations, so I'm going to bring this -3 down. And now I'm just going to distribute that -3 in. Lots of multiplying, that's why it's the order of operations. So I get -3x squared. When -3 meets the minus 2x, I get a positive 6x. And when -3 meets 1, I get a -3. And then I'll uncover that last sticky note, bring this 5 down, and finish my adding and subtracting, hence the order of operations. So I'll just combine those. And if you struggle with adding and subtracting with positive and negative numbers, then get a calculator, and it's -3, take away 5, which is -8. So now in standard form, I got the y-intercept of 0, -8. And up here, I got the vertex of 1 and -5. So following this video, you should have a little practice. It'll say something like week 15, assignment 1, or not week 16, it's 15, it should be week 17. So you're going to try that, and then don't forget to check your answers.